Although there were some correction filters trying to address the problem boundary effect, they all cannot solve it thoroughly. In this paper, we present a novel correction filter without boundary effect to solve this problem thoroughly. We also present two algorithms to accelerate the contraction of kernel matrix. Our tracker outperforms all correlation filters which aimed to alleviate the boundary effect. These are KCF's regression function and optimization problem. The sets of X and XST are cyclic and identical. It's clear that both the high speed and the boundary effect of KCF come from the cyclic samples. In our filter, the regression function and optimization problem is different from those of KCF. As shown in the right figure, Z is the set of cyclic bases and X is the set of real samples. The high speed of our filter comes from Z, and the real samples X made it avoid the boundary effect. The efficiency of contracting K depends on the efficiency of the contracting autocorrelation of X and the cross correlation of X and Z. Each dot product of the autocorrelation can be expressed uniformly like this. As shown in the left figure, there are high overlapping between neighboring samples. Thus, there exist large amounts of redundant calculations. To remove this redundancy, we design axes to calculate the autocorrelation efficiently. The element of the squared integral image is calculated with this, then each dot product can be got in a constant time. The cross correlation can be expressed as this. The pentacle is the correlation operator. Because all Z, ST are cyclic, there exists large amounts of redundancy in calculating the column vectors. In fact, these two dot products will be performed many times. To remove the redundancy, we propose the integral matrix to calculate the cross correlation efficiently. The dot figures show that each basis can be decomposed into 4 parts according to the location of its Z00. Then, each correlation can be decomposed into 4 items. The redundant calculations come from two sources. One is the dot products. If all dot products are calculated and stored in advance, each of 4 items can be obtained by first retrieving the stored calculations and then summing them. This way, the redundancy on the dot products is removed. The other source of the redundancy is the summation. We'll design the integral matrix to eliminate the redundancy. These tables show that our acceleration method is much faster than FFT, and our filter is faster than all correction filters which aimed to alleviate the boundary effect. Our tracker outperforms other correction filter trackers. More experimental results can be found in the paper and supplemental materials. Without the boundary effect, being able to exploit nonlinear kernels and run at high speed, our filter possesses all these characteristics that were hard to manage simultaneously before. Since 1964, all correlation filter-based pattern recognition techniques have to rely on FFT to efficiently work. From now on, our filter provides an efficient and more powerful alternative without FFT. Thanks.